Greetings all. Welcome to week 5 of term 2, week 4 of learning at home. Hopefully by now you've all done your tests, and I'll get those to you or the results to you as soon as I can. We need to move on, of course. We've got more to plough through. I've chosen for our next unit as measurement because it's one I believe that you can spend quite some time on with relatively little input from me. The reason I say that is, if you look at what I've got as our goal for this week, it's simply working on area. From area we're going to progress into surface area and then volume, but there are in fact 3 generic steps which will apply right through this unit. Similar, I suppose, to with our trigonometry. Once you had the method I taught you down pat, you could essentially apply it to all situations. It's the same here. All you need to do to calculate as we've got with this work here is to write the formula first, then substitute, then answer the question. The key thing, the one I want you to make sure you do, those of you not real flash on setting out, or those who have a tendency to laziness will find that a bit of a burden, but it makes life easier. The example I've got over there, which will be the last one we'll do today, should demonstrate why this is just a very powerful way to go. Now, having said that, the theory with the formulae listed is on page 405 of your text. The examples are going to be taken from the subsequent pages, so just now make sure you have your books open to page 405. Check to see that you've read through the theory at the top of the page there, the first half of the page. And in particular, you've got the area formulae for the 2-dimensional shapes. And that essentially is going to be our work for this week. Once you've got a handle on those formulae, I'm then going to work through from example 7. So you need to come over the page to page 406. In example 7, there are 3 problems. In each case, you are to find the area of the basic shapes, correct to 2 decimal places where necessary. So, as I said, step 1, write the formula. Of course, you've got to write the right one, the correct formula. So if you're not sure, have a look at the shape in example 7a. What is it? If necessary, back over the page. Right, it is a trapezium. What is the formula? The formula for the trapezium is that the area is a half a plus b multiplied by h. And you need to identify what a and b are. From your theory page, page 405, looking at it, you can see that a and b are the parallel sides and h is the height of the trapezium. So then from the data given in example 7, the 2 parallel sides for the trapezium are 3 and 5 centimetres. Doesn't matter which way around you put them because you are adding them together. So one parallel side is 3, the other is 5, and you are multiplying that by the height of the trapezium, which is 2. Now, there'd be some knuckleheads out there would get their calculator out and do that, but others with a few more smarts would realise that a half times 2 is 1 and 5 plus 3 is 8, so your area is 8, is it centimetres squared. Don't forget, square units now for area. So that's 7a. Moving on to 7b, looking at the shape, it is a triangle. You should know the formula for the area of a triangle. If not, look it up, back on page 405, a half BH. By the way, when you come to do assessments on these things, you will be provided with the formula on your test. So you don't have to actually remember them, but of course you need to recognise which goes with which shape. B stands for the base of the triangle. From our data, it is 5.8. 1/2 times 5.8. Again, multiplied by the height of the triangle, which is 3.3, and in this case common sense would dictate that you would use your calculator and get an answer of 9.57 metres squared. Our third example is a circle. Area is pi r squared. Trap for unwary players here, you're given the diameter of the circle, 1.06 kilometres. R stands for radius, therefore we need to ensure that you halve the 1.06 to get 0.53 as your radius, and then that in turn has to be squared. Punched straight into your calculator as is, pi function down the bottom, multiplied by 0.53 squared, rounded to 2 decimal places as required, 0.88 kilometres squared. So you can see in each case, what I did, I wrote down the correct formula for the particular shape. Trapezium, triangle, circle. All I needed to then do was to identify the numeric values for the particular dimensions involved, substitute them in, and the calculator will do the rest. Example 8 looks at what happens when you need to apply a little bit more mathematics, but the idea is that this generic method still applies. In 8a, if you look there on page 406, you can see that you've got a rectangle. Its area is 11 millimetres squared. It has a width of 2.3 millimetres, and you need to calculate the length. Same steps. Write the formula, even a basic one, like the rectangle, A equals LW. Substitute, what do we know? We know that the area is 11. The length is unknown, the width is 2.3. Once we've got it written out like that, you can see that this is just simply an equation, very simple equation. We've done work on solving equations in term 1. So the L is calculated by inverse operation. We have to divide both sides by the 2.3, and 11 divided by 2.3 to 2 decimal places is 4.78. And in this case our units are millimetres, so our answer is 4.78 millimetres. Note they're not squared now because we've got units of length, not units of area. B is a little bit more involved again. We've got a trapezium. Look at it there on the bottom of page 406. So what have I instructed you to do? Write out the rule. Then substitute. Do we know the area of the trapezium? Yes, we do. It is 0.5. Half multiplied. Do I know A? The answer is no. A is given there as an unknown. Do I know B? The answer is yes, that's 1.3. And do I know H? The answer is 0.4. And we now have a more involved equation to solve, but it is still relatively simple compared with some of the equations you've solved before. So a little bit of simplification first. So 0.5 is equal to a half times 0.4 is 0.2 multiplied by A plus 1.3. I'm going to present the solution slightly differently to what's in the text, because from this point you do know that you can divide by the 0.2, and if you want to do that first, that's fine. If you're a little bit uncertain about your equation solving, expand your brackets. And so we've got 0.2 times 1.3. Some of you might need to do that on your calculators, but 2 13s are 26, so this is 0.26. Once you've got it to that stage, we've now got 2 steps to solve the equation. We would subtract 0.26 first, That would give me 0.24 is equal to 0.2a, and then we would divide by the 0.2, which would give me 1.2. So A is 1.2, and again checking the units, 1.2 metres. Moving on to our last two examples. In example 9a, checking there on page 407, you can see that we have what is called a sector. Now a sector is a part of a circle, so you need to regard it as a fraction of the circle. And the way it works is this. The area of the circle is pi r squared. But I don't have a full circle. I've got 80 degrees of it missing. Look at the angle there in the centre of the circle. So with the 80 degrees missing, then you've actually only got 280 degrees of the circle involved. So you've actually got 280 360ths of your circle. So simply, it's the formula for the circle with 280 over 360 there. You simply then leave that as 280 over 360. You've got multiplied by pi. Your radius of your circle is 3 centimetres, so we have 3 squared. And to 2 decimal places, we have 30.37 metres squared. So that is a particular variation of the circle formula. Harkening back to what I said earlier, back over here, our generic steps, write the formula, substitute, answer question. Look at how easy it makes this one. Look at that shape. How would we find the area of that? Well, the fact is, it's in two parts. I've got a square here and this funny little bit here. And the trick is to realise that that funny little bit there is actually a square with a quarter of the circle, oops, that's a good effort, quarter of the circle taken out. So, how do I find the area of this thing? Well, write the rule. The area of a square is L squared. So for this bottom square, note the dimensions, 5 metres, all the way around. So it's a square. And then we have the area of the top square. So we have another square. But it's not the full square. It's got a quarter of the circle taken out. How do we do take? Subtraction. How do we do the area of the circle? Pi r squared. But it's not a full circle, it is a quarter of a circle. And that is essentially the thinking step for this sum. If you can do that, you've effectively got it nailed. Because look at what the formula is saying. My area is made up of a square, another square, but then with a quarter of a circle taken away. All we need to do from there is the length of the square is 5. The radius of the circle is 5. You just put the numbers in exactly into the rule as it is presented, and then the calculator will compensate for order of operation, will actually do the sum for you. And the answer to this one is 30.37 metres squared, which means, as most of you, or in fact all of you would have picked up, I made use of myself over here by reading the wrong answer. This one here, let's just harken back up or back across. For the solution to A is 21.99 centimetres squared. So just go back and correct that for you. But again, I emphasise, have a look at how easy this was compared with what you might have thought with looking at it in the first place. all comes back to write the formula first. If you write the formula, then the rest just drops out. So fairly achievable goal for this week, mainly revision. You're looking at calculating area of plane figures, and we'll move on to surface area next week. Good luck with it, and don't forget, call me on chat if you need help. Bye for now.